So welcome back. If you are watching this video, you should have completed Investigation 2 in your Discovery Math textbook. And we're just going to jump right in. Just a quick reminder of what our essential question is. We're looking to evaluate algebraic expressions so that they reveal to us what's going on in our situations. So our first example, we're going to reach back into Investigation 1 in our last video. We're going to do a little bit more practice, and then we'll use the example we develop here, this expression, in our example 2. So if we're asked to write an algebraic expression, let's use green pen, for the quotient of a number squared and 6 less than the number. So we have to remember that quotient is divided by. So every time you see that fraction line, that tells us divided by symbol. So we're going to set up a fraction. So the quotient of a number squared. So any number, I'm going to call that number n, and I'm going to square it. And so the other part of my quotient. So this is a case where and does not mean plus or addition. It means the second part of my quotient. So my numerator is n squared divided by 6 less than the number. The number was n. So now I'm going to take n minus 6. So that's 6 less than the number. So we're going to move on to example 2 and use this expression in our example 2. So our second example digs into what we looked at in Investigation 2, evaluating the algebraic expression. So we're going to look at this n squared divided by n minus 6, and we're going to look at that expression and think about this word evaluate. So what does it mean to evaluate that expression? So if you're asked to evaluate it, we're going to substitute a value for the variable. And simplify. So evaluate means to substitute a value for the variable. So let's make a table. And so I'm going to just do, let's see how many I can do on this slide. Bring it all the way down here. This is going to need to be bigger. Sorry about that. Myself lots of room. And I'm going to say that here is n, and here is my n squared over n minus 6. So that's how you start your table always, with your variable and then your expression. Let's make that look a little bit more like an exponent. And so let's try the first one. Let's evaluate this if n is 0. So what I'm going to do is I'm going to substitute a value, n equals 0, for the variable, and then I'm going to simplify. So I'm going to put 0 squared. You can see where I did not leave enough room to make this clear for you guys, so let me go back. Over 0 minus 6. And then I'm going to simplify that. I'm going to solve. So 0 times 0 is 0, divided by negative 6. And when I simplify that all the way, it's 0. So let's try that with 1. And then we'll try it with 2. So 1 squared over 1 minus 6. See, I'm substituting the value 1 into my expression. So n becomes 1. 1 minus 6 is minus 5. So that's my final answer, negative 1 over 5. And now what if I substitute for 2? 2 squared, 2 minus 6. Every place there is an n, I'm putting my new value in. So in this case where there was an n, I put a 2, and then I took it out. 2 squared is 4 over 2 minus 6 is minus 4. And when I simplify, that's minus 1, negative 1. So that's how we evaluate an algebraic expression. Okay, our last example. Now we're going to kind of do the reverse. So now we're going to have a table with numbers in it, and we're going to find out what the expression is that represents what's going on. So here's our problem. We're going to let T represent the number of hours that an air conditioner technician spends on a service call. So your air conditioner's broke, call somebody out. T is how many hours they're going to spend fixing your air conditioner. And we're going to use a table of values to write an expression. T is the number of hours that represents the cost. We want the cost of the call. Because if he spends an hour, it costs less than if he spends 5 hours, right? Here's our table. So here's how we tackle a problem like this. We start looking for patterns. Math is all about patterns and sequences. So we're going to look for patterns. And the first place I always look for patterns is I subtract and see if there's a pattern, like if each one of these is the same amount apart. Like, is there a certain dollar amount per hour that we're being charged? So I'm going to look at 75 and 110. So 110 minus 75 equals $35, I believe. Can count up, 85, 95, 105 plus 5. Excuse me, okay, count down. We could use our calculator. Now I'm going to look at the next one. I don't know anything until I do a couple of these. And this is also $35, 145 minus 110. And let's look at the last one, 180 minus 145. Again, 35. So we can see that each hour of time that he spends adds $35 to our total cost. So that's going to tell me that 35 times the number of hours is going to be part of my total cost. So let's use C to equal cost. So it's going to be 35 times T, or the number of hours. And that's going to get me at least part of my cost. But let's look here at the first hour. If the time equals 1, 35 times 1 is only going to be $35. But that's not true. Not true, because when T equals 1, cost equals $75. So we have to think, maybe when there's a service call, there's like just a flat fee. If they spend 2 minutes, you still pay this dollar amount, and then you pay per the hour on top of that. Pretty common way to charge for things, right? So let's check it out. So if 75 minus 35, what does that equal? That's $40. So what if I add $40 as my initial fee for just making the service call? And what we're going to do is we're going to check this. So we're going to check and make sure we're right. I'm going to say T equals 2. So 35 times 2 plus 40. That equals 110. So that's true. Let's try T equals 4 and see if it checks out. $35 times 4 hours plus 40, and that equals 180. So that is also true. So to solve a problem like this, we look at the table, we check for differences, and we see if they're the same each step of the way as we go up 1 hour at a time. And if they are, then our problem is tackled by taking that number we're going up each hour or each mile or each gallon or whatever it is we're looking at, and multiplying it times, in this case, 35, whatever that standard amount is going up every time. So our variable times that number, and then we have to check and see if that works. And so there might be like a excuse me, rate that we pay at the beginning, and we have to find that. And then we just check our work. And that's how we would tackle a problem like this. So I will see you in our next video. When you've completed this video and you understand these examples, you can include them in your notes or not, it's up to you. Then you're ready to move on to investigation 3.